So another bit on doing work. Let's imagine then let's go back to this example of the car. And let's say that the car begins not moving. So we can't say it's got no energy, but what we can say is it has got no kinetic energy because it's not moving, okay? So it's at 0 meters per second. And remember kinetic energy equation? Kinetic energy is 0.5 times mass. Let's just give it a mass of 1,000 kilos times 1,000 times the speed squared. Now, of course, 0 squared is just 0, so that means the kinetic energy is equal to 0 joules. But then let's say the engine starts moving the car, and then after a certain amount of time, so let's just do that, okay? Certain amount of time, then the car is moving with some speed, let's just say. Let's just say, again, keep it simple, we'll say 15 meters per second. So now we can get the kinetic energy. Kinetic energy is 0.5 times the mass, 5 times 1,000 times 15. Don't forget this, squared. So I like to just do this step by step so that I can spot any mistakes I might have made. 0.5 times 1,000 is 500 multiplied by 15 squared. Kinetic energy is 500 times 15 squared. Let me just grab a calculator. I'm pretty sure it's 225, but just want to not do that in my head because I can't multitask very well. Whoops, 15 squared equals, 225. 225, and then finally evaluate that. Kinetic energy, 500 times 225 gives me 112,500 joules. Remember, in energy, you do tend to get quite big numbers. So, what we can also see from this is that the engine has done a certain amount of work to give it this amount of kinetic energy. Now, again, we're thinking about this in simplified terms. For example, if we ignore air resistance, it makes things much, much simpler. But anyway, that's the amount of work that has been done by the engine in this case. What we can also then say is if, for example, we knew the distance, we could figure some other things out as well. If we knew the distance, we could work out what the average force produced by the engine was. Because remember, this is the work that has been done by the engine to make the car move, to bring it up to this speed. We don't need to proceed much further than this for the purposes of GCSE. If you can do this, then you're absolutely flying. We don't need to go any further than this other than at A level. And we get a whole suite of other equations we can use to figure things out. Now, let's also think about other ways we could do work. No, let's not think about that right now. So I think that's everything that we need to talk about in doing work. I think it is, yeah.